Hi everyone, I am V. Balaji, mechanical engineering student of Madras Institute of Technology, Anna University. Okay, what is a boiler? A boiler is a closed vessel in which fluid, generally water, is heated. Hot gases are produced by burning fuel in the furnace. Then these hot gases are made to come in contact with the water vessel, where the heat transfer takes place between the water and the steam. Note that the fluid does not necessarily boil. Therefore, we can say that the basic principle of the boiler is to convert water into steam by using heat energy. Formation of steam. We can notice the graph between temperature and heat. Here, by heating the water, the temperature of the water increases gradually with a constant slope. Here, by reaching this B point, it is since it is the boiling point of the water, that is 100 degrees Celsius. Then, by continuous heating, the evaporation takes place by changing it into wet steam. Still, by increasing heat energy, the temperature also increases and the pressure also increases, since it is called the superheating condition of water. See, we can notice that in this above saturation line, it is called dry steam, where the C to D point is called superheating temperature of the water. Here we can see the boiler and with its components name marked in it. It is a type of vertical fire tube boiler. See, we can notice the ash pit which collects the ashes and the grate where the steam flows in, and it is the combustion chamber, and here is the boiler shell where the water flows, and feed control valves and water gauge and um, water level indicators to measure the water level, and it's the manhole where a man can enter and clean and check the steam space, and it is a stop valve and it is the pressure gauge to indicate the amount of pressure, and it is a chimney where the exhaust waste can be get out, and it is a damper which collects the excess heat removed in the chimney, and it is a door. Here is the fire tubes and the fusible plug. We can see the important parts and its functions in the upcoming slides. The above seen figure is a vertical fire tube boiler. Here we can see the process inside the boiler. Fuel is fed, fuel is fed and burned in the grate, which is a large space, and hot gases go to the combustion chamber, where the combustion process takes place. The hot gases pass through a large number of fire tubes and the heat the surrounding water and convert it into steam. Since the steam is lighter, it goes up to the steam space. The waste gases enter the smoke box and are released through the chimney, where the exhaust gases goes out. When the damper is partly closed, the number of waste gases leaving the chimney will be reduced. Hence, we can see that the damper controls the rate of steam generated itself. Here are the important boiler mountings. First, we can see the water gauge. We can see this diagram and we can understand that here is the water level marker which indicates the amount of water, and here is a steam cock and a water cock. Steam cock which closes and opens the amount of steam to be inserted into this cylindrical pipe, and it is a water space where the water gets in this chamber, and it is a gas gauge which represents the uh, which indicates the amount of water in the water level indicator. Okay, small capacity boilers are made with a thick glass tube with the necessary protection and safety devices. Since it is a very thick glass which can withstand high temperatures too. For automatic controlling using a float mechanism, the water level will be kept constant with the help of a feed pump or a water injector. According to boiler regulations, two water gauges should be fitted in each boiler. One one with each should be available to the operator to clearly visible. Here is the pressure gauge. It is used to indicate the pressure of steam inside the boiler. At atmospheric pressure, the gauge will read 0. Periodically, the pressure gauge should be tested with a standard gauge and calibrated if necessary. Since it stands in a high temperature, it can be show deflections. Depending upon the pressure, the spring tube will deflect. This deflection will be magnified to the pointer through the link mechanism consisting of a rod, toothed sector and a pinion. Here we can see the toothed sector, a pointer which shows the amount of pressure in the pressure gauge, and here is the U tube which connects with the flange where the steam inserts in this U tube. And here is a cock which opens and closes, which acts as a valve, and here is a spring tube, and here is a hinge point and a rod which shows the last point of the pressure gauge. It is a safety valve. We can see it from this diagram. It consists of a spring and a bridge-like structure which has shackle, and here is a lever which has two valves in each port and a pivot-like structure. Okay, come let's see. This valve, it is designed to open and let some steam out when the pressure exceeds the safe design valve. You can remember that in kitchens we use the pressure cooker, and it has a knob like structure above the lid of the cooker which exerts some pressure. When high pressures are increased inside the pressure cooker, it lets out some steam. Similar to it, there are some two types of safety valves. One is called lever safety valve, and it is another one is spring safety valve. The pressure exceeds the designed valve. The spring should be pushed up and opening the valves and letting the steam out, as I said before. Fusible plug. It is one of the safety devices in many boilers. It prevents overheating of the firebox and other parts of the boiler. Here we can see the gunmetal protection and a fusible metal which has two rod-like structures inside the body. Here is the flange and here is the inner plug. In this case, the water level becomes too low due to failure of automatic control. The plug will melt and create an opening through which water and steam will be allowed to put out the fire in the grate. The plug is made of a special alloy which has a comparatively low melting point like gunmetal type and fusible metal. Here are some other mountings which is also used in boilers. The first one, main steam valve. It is used to regulate and stop the flow of steam going out of the boiler to the turbine, engine or process valve. Blow off valve. It is fitted at the lowest level of water. It helps to remove the salt deposits and other impurities accumulated in the bottom portion of the boiler shell or drum. This valve should be periodically opened, keeping the steam under low pressure of about 2 bar. In the upcoming two slides, we can see some important types of boilers, namely fire tube boiler and water tube boiler. Here, we can see the features of fire tube boiler. Hot gases pass through the tubes with water surrounding them, but in water tube boiler, we can see the similar case as I will differentiate it. Used fire tube boilers are used for low pressure steam as the diameter of the shell is large. The pressure is restricted to about 10 bar. More steam space is required, so fluctuation is very less. Transport is difficult due to large shell diameter. Thermal efficiency is low. Water circulation is very poor. It is used for industrial applications only due to low pressure. Here comes the water tube boiler. In difference to fire tube boiler, the water tube boiler has water passes through the tubes with hot gases surrounding them, since the vice versa is fire tube boiler. Drum diameter is less and it can be used for medium and high pressure tube. Pressure of steam can even go up to 100 bar, which is really high than fire tube boilers. It requires less steam space, so pressure fluctuation is more when the steam is taken out. Transport is comparatively easier due to smaller drum space. Thermal efficiency is really high. Water circulation is better than fire tube boiler, and it is used for power plants where we need high pressures. Here comes the advantages of water tube boilers over the fire tube boilers. Water tube boilers can be steam can be raised more quickly and steam at high pressures can be produced, that is about 100 bars, and higher rate of evaporation and sedimentation deposition is very less, suitable for any type of fuel and method of firing. More effective heat transfer. Failure of water tubes will not affect the working of boiler. Occupies less space, easy maintenance and easy transportation, which gives the water tube boilers more efficient and performance improvement. Rather than advantages, water tube boilers have to disadvantages over the fire tube boilers. It is not suitable for ordinary water and it is not suitable for mobile applications and it's high initial cost and hence not economical for many. In many spaces and industries, we use high pressure boilers. So we can see the advantages of high pressure boilers and namely high pressure steam out of the boiler will have higher heat energy per kilogram. So the power output from the turbine and the generator will be really high. The thermal efficiency of a high pressure boiler is much higher than that of low pressure, medium pressure boilers. Evaporative capacity of the boiler is high due to forced circulation of water. The investment cost for each MW output will be really less by using a high pressure boiler. And here comes the last characteristics of a good boiler. What's a good boiler? Which is very efficient and economic to us. The boiler should be able to evaporate steam at the desired capacity, pressure and temperature. Total cost of the boiler with all mountings and accessories should be very less. By having high thermal efficiency, the operational cost should be low. The boiler should have a provision for the inspection of all the parts for cleaning and maintenance. The boiler should have a provision for automatic control of water level, pressure and temperature since the operator can be really easy to operate the boilers. The parts should be able to withstand fluctuations in high pressure and temperatures. Transport and erection of the boiler at the site should be really easy and at the minimum cost. Here we come to the end of my PPT presentation video. I will recall the above topics once again. We have seen what is a boiler and formation of steam and boiler and its components. Some important boiler components like pressure gauge, water gauge, fusible plug with its representative diagram and some functions of it. We have seen fire tube boiler and water tube boilers and this advantages and disadvantages over them. We have seen high pressure boiler advantages and what are the characteristics of a good boilers and how are they used. Thank you.